What I do is I want to do project 410. Let me bring it up here. It's in the kernel debugging. All right, this is the first kernel debugging. Now, as I mentioned before, when you do kernel debugging, you normally need two machines connected by a serial cable or perhaps an Ethernet cable if you're using a more modern version of the tools, because when you put a breakpoint in the kernel, it will stop your machine and you need the other machine to take control. However, we're not going to have two machines in what we're doing here. So the way to get around this before, until recently, was to use this thing called LiveKD. And if you're using the old Windows 10 machine I made, do this project exactly as written. If you're using an ARM machine, then look for the red boxes, which are the changes for ARM. So in either case, you install debugging tools for Windows. It's the same in both cases. You go here, download this installer, and then you choose to install debugging tools for Windows, and you can clear everything else so you don't waste time. It doesn't matter if you install this extra stuff, but all we need is debugging tools, and that's about half a gig. Once you're done, then you have to perform these command line commands in an administrator. Then you have to install this in the administrator command prompt or PowerShell or terminal. BCD edit. This is boot configuration data, and this is how you tell your machine that this machine is going to be debugged. It turns on debugging, and it sets it to debug locally, which is a new feature. All right, then you have to adjust the path so it can find WinDebug, and after you install it, it installs stuff in this weird place, C program files x86, Windows kits 10, debuggers x64. Now this is Microsoft being weird. I don't know why Microsoft has 64-bit code put in the 32-bit program files, but it does. And if you're using ARM, it puts the ARM 64-bit in the x86 program files folder, which is a weird place to put it, but that's where it is. So you have to add that to the environment variables here so your machine can find it, and then you can launch WinDebug. Now, you used to need this LiveKD thing to trick your Windows system into effectively looking at a crash dump so you can debug the kernel on a single machine. But now you don't really need it. And so LiveKD will not run on ARM, and you don't really need it anymore. So all you do is you just run WinDebug directly, and that's what I'm going to do here. So I've got my, I've already installed that tool, Microsoft debugging tools in this machine, and I've reset the machine for local debugging with BCD edit, and after that you have to restart the machine, and now you can just launch WinDebug right from an administrator terminal or PowerShell or command. So I got a PowerShell window here. I just run WinDebug, and here it is. The first time you load it, you have to agree to the terms and answer a couple of questions. And then you've got it. And now I don't need LiveKD anymore because you can do file, debug, kernel debug here. And there are various choices. And you can choose local, and it will debug this local machine, which is very nice. And that's essentially what LiveKD did. So now it loads. And the first thing it does is show me information. I'm running Windows 10 kernel, which is kind of funny because this is Windows 11, but it thinks it's a Windows 10 kernel and has general information. Now, the way this thing works is you put a command down here at the bottom, and it puts the answer up there. I don't know why they didn't just make it a command line tool, but they didn't. So LM will show the loaded modules, and you'll see I have one called NT here, which is NT kernel. NTDIL, that is the basic kernel functions, and then there's some other things loaded here, things like drivers and such. So now you can just practice using this WinDebug tool here. By the way, the Microsoft insiders call it Windbag. That's probably a joke or something. But anyway, let me just bring this up here. So we're going to look at the loaded modules. And then you can, to observe memory, DD will display D words, ASCII, bytes and ASCII text, and DT. So if I display both bytes and ASCII for NT itself, that's here, DB NT. and it shows me the start of the Windows NT OS kernel. And it is just like every Windows executable, always starts with MZ as a flag, and then it always has this message, this program cannot be run in DOS mode. So you're seeing the first few bytes of that program. Now you can search for symbols, labeled symbols. So if I want to examine all the kernel functions, I do X NT bang star. This will tell me all the symbols in the NT kernel. And there are thousands of them. These are all the symbols, including all the functions and other things. So that'll take a while. But if I want to see a smaller set of them, I can put in star create file star, and I'll get the ones that include the words create file there. And now there's only about 15 or 20 ways to create a file in Windows. All right. One of them is NT create file, the simplest one, the one I think that's used by Notepad. So I can unassemble that function. U unassembles a function, NT bang, NT create file. And when you do that, you're going to see the first few bytes of assembly code here. And notice this is not x86 assembly code or x64 assembly code. This is ARM assembly code, so it looks kind of different. But the name of the function and the purpose of the function is pretty much the same. Microsoft ported their stuff from the Intel processor to ARM, and they didn't change it very much. But if you want to see more of it, you can use L for length and specify a hexadecimal number of more stuff to see. So I can put in L20, and now it'll show me the first 32 instructions, 2 times 16. So notice that file goes down to here where it's done and does a return. Then there's some zeros, and then the next function starts, which is NT create named pipe. So I disassembled 32 instructions, but some smaller number, like only 28, is what was in that function. All right. Now, if you want to, you can also examine a driver object. I can do DT NT bang underscore driver underscore object. This is the data structure that is used to store information about drivers. And so you see there's a type, a size, a device object. There's a driver name, which is a Unicode string, and so on. There's various objects. These are the objects that have a driver. Why does L20? Because the 20 is in hexadecimal. And by the way, I'm right on time you asked that. To learn how to use the kernel, this is how you learn it. You do .hh, and this opens Windows 3.1 help pages, left over from before Windows 95. And that is where all the information is. So now you search, and for example, what I was doing there was unassemble. If I type U and search for that, I will find unassemble. And if I go here, this is where you find out what the parameters are. And someplace address length there. If you use the B flag, you must specify range by using the length flag. And someplace it's going to tell me that the length flag is in hexadecimal. Now, if I want to learn about the examine command, I give it an X and search and go here. And this is where you can learn the flags that let you control what you're doing in the examine flag, which is one of the main ones you use a lot. And this is how everybody learns how to use WinDebug from this thing. Better than any textbook, better than anything else. This is how you learn how it really works. All right. And now you got some flags to find just using those few commands. I ask you to find a function name with a certain pattern, like 2 characters, then registry key, then 6 more characters. And here you find disassemble the shutdown system command and find a flag here. And here, if you're using ARM, ignore the first 2 flags and use the second one. I'll change this one to red later. Because on ARM, the flags are a little different. Because there's some differences. The WinDebug works fine, but I couldn't find anything fitting exactly this pattern anymore. The pattern's a little different. It's NT, then 4 characters, then registry key, that sort of thing. And this actually ends up having the same flag, but the assembly code looks different on ARM. So, I'm glad you can still do it in either case, but the steps are a little bit different depending on your hardware. So that's all I wanted to show you. Let me stop recording this. Oh, good.